nowadays also are to basically to provide for occupant comfort. So it's not only thermal comfort, but all kinds of comfort. It's also lighting can also be part of occupant comfort, and ensure that there is an efficient operation of the building. And also the reduction of energy, optimization of energy usage is also an important part of building automation and building control to ensure that things don't get out of hands, and these individual systems run at full capacity when it's not needed. And by that also improved life cycle costs or life cycle of utilities and life cycle control of these utilities that are being installed. So it's a little bit like that this control system is not at a very specific place in a building, but it actually involves almost the entire building volume, wherever there are kind of technical equipments being installed that need to be operated and need to be controlled, and then this building automation system also comes into play. So there may be a central location, usually a room where that is nearby, where building administration is working, but it can also be at a separate place in a basement or at the floor level where larger building equipment is being installed, such as, for example, the HVAC plant, where most of the HVAC equipment is being installed. This is usually like a centralized area where then the control mechanisms or the control station is being allocated. But still, like usually any kind of building equipment that needs to be controlled or wants to be controlled and wants to be regulated and wants to be measured, that requires for installation of some equipment for building automation. And again, there will be either a wireless, but most likely actually a cable infrastructure put in place in order to connect all these equipment pieces with each other, to provide feedback, to signal information back to the control system itself. So it's usually a computer network with electronic devices designed to monitor and to control. And again, there are many, many different kind of systems that are typically installed in the building that are usually controlled and operated separately. However, all this information comes together into one main control system. And the systems that I mentioned, I can repeat them one more time, that can be security related, that can be fire safety related, that can also be resilience related, such as flood safety, whether there is flooding in basement or in vulnerable areas, lighting control, emergency lighting, thermal control, humidity control, or air quality control. All these things are interconnected. The same thing could be alternative ways of electricity utilization, such as renewable energy systems or renewable energy sources are also then interconnected. And the centralized system is supposed to be put in place to keep all these things running smoothly, and to make sure that they cannot be interfered and meddled with. So by that, there needs to be a safety mechanism to ensure that no one can control these systems from outside, and it only gives access to individuals that have the right, that are entitled to, or that have the right to do so. And by that, this is actually also a vulnerable spot of a building. You see it from many movies, kind of spy movies or crime movies where these building automation systems are being disabled or put into are being accessed in order to control building mechanisms. And most commercial, institutional, industrial buildings have a very specific control and communication system. There are actually 2 or 3 different types that are kind of like certified systems and that are widely used. And this basically running on a digital code that is different from traditional computer operating systems, and it has its own communication protocol. And as we are moving on with digitization in our lives and as well as buildings, these control systems are not only anymore just controlled by individuals, by humans, but they're also being enhanced through automation systems, and also later on, or nowadays also through artificial intelligence systems to improve actually the operation and to improve the services of the building automation system itself. So again, like on one side, you have actually a very robust, independent computer protocol. One example is called BACnet, which is independent from conventional computer operation systems, has its own protocol, has its own coding in order to make it independent and make it also less vulnerable. And at the same time, actually, it's getting more and more enhanced, and the use of computers and computer technology is getting more and more present in this building automation and control systems, which often increases the risks of people gaining access to it. And these are some examples of how these smart operations or smart intelligent, smart building control systems become also accessible by individuals. This is often tested or often practiced in residential designs, where people want to control their own thermal comfort or their lighting comfort and so on individually, and like to do that from either central spots or by nowadays like to do that by using their smartphones, by accessing the automation system that is installed, or some accessible areas such as their individual rooms, to get access to it and then to individually control airflow or temperature or lighting settings, etc. And this is what we call room automation. So that's a subset of actually building automation, where in individual rooms, people have access to some of the parameters of building control and then are allowed to modify them according to their own needs. And this can actually do, I think, can be done through these touch screens or can be done through smartphones. It depends on the advancement of the system and the purpose of the systems. Some other room automation features are, for example, more related to office design. So, for example, you can actually control the indoor air quality. That can go all the way to PM 2.5, which can measure the interior dust pollutions. For example, if you have copy machines in an office room, that actually releases a lot of PM fine particles. That's why nowadays actually a lot of offices request that actually any kind of printing equipment is in separate rooms and is not part of actually the office room or office space, because they release fine dust. But also, actually more importantly, the control of carbon dioxide in the rooms to make sure that the productivity of people is not compromised, because the more people are in a space, the more people they breathe and work, and there is not enough access to fresh air supply, the more the productivity will be reduced in this area. So these are basically all kind of controls that supposed to help with the productivity of the people in the interior spaces. Another one is occupant presence. Occupant presence can help with controlling the amount of cooling or fresh air supply into interior spaces, and again, like, can help with energy saving, but also can help to ensure that there's always enough fresh air being provided for, as well as VOC measuring. VOC is basically any kind of it's not a dust, but it's basically volatile organic compounds. They usually are basically emissions from mostly plastic or oil-based products. So any kind of paint, any kind of plastics, they usually release or they emit chemical compounds into the air, especially when they are freshly produced or freshly made or freshly painted. You can actually also smell it. You can smell the paint. Usually it's a little bit, it causes some headache to people. And this is usually done by these volatile organic compounds that are being released. So these are gases, actually, gas emissions that come mostly from actually oil-based products. And especially in newer buildings, the amount of VOC in the interior spaces is usually higher than in older buildings. But this also very much depends on, again, like the products, the materials that are being used in the interior spaces. And another one is relative humidity. So these are all kinds of room automations or sensoring and measuring equipments that are installed in the most recent office buildings or in order to ensure safety, health, as well as productivity of the people working there to improve the interior conditions. And also the request for sustainability or for more energy efficiency is also an important aspect of building automation systems, because again, like with be able to controlling and measuring, you can also optimize then the amount of cooling needs or heating needs, as well as the amount of fresh air supply and the control of the equipment that is responsible for all these features. This is usually how it looks like as a symbolic design, that you have actually hardware components. And these hardware components are usually physical devices, often referred to as sensors or actuators. So these sensors are usually the physical devices that are responsible for measuring some physical condition. So for the amount of daylight, or the indoor air temperature, or the indoor air humidity, or the presence of people in the room. So these are usually sensors with a very unique specific function, and usually either with an yes/no reply or response, or with a more gradient, more fuzzy response of, for example, a specific number, such as the temperature, or basically a fraction of an amount, for example, the occupant presence. So here the measuring, the sensors have a very important function, because they provide the information to the computer system, to the microcontroller, that then provides a link to the software component. And usually the software component can do not only can put the data that is the real data that is being collected and put that into context with each other, and then make the decisions, automated decisions based on that. Automated means like that there is a certain response that is being programmed. So for example, the indoor temperature falls below so in a cold climate falls below 20 degrees, then the information, or then the automated response would be that the heating needs to be increased in order to maintain higher temperatures. In a colder climate, usually people feel comfortable with 21 degrees. In a hotter climate, people usually feel comfortable with 24, 25 degrees. So again, like these control systems then define what are the human comfort ranges, or what are the required or the requested ranges, and then they would activate or deactivate certain controlled systems. And these are then actually the response are then basically the activations of these building systems. So that's why we call them actuators. So the sensors actually measure, the computer has an automated response, and then the actuators are the ones that are actually then putting in action certain requirements. So for example, increasing the air temperature, reducing the humidity, shutting down the blinds, or closing some doors, locking up some doors, etc. So all these control systems require actually the sensors, actuators, and in the middle they actually have then the computer system with the related software that puts all these things into action. So that's the basic idea. And again, like the exposed device objects are actually then the devices that actually being put into action, and the software devices are actually then motors, sensors, lamps, and so on, and that are being actuated. So I also try to make this a little bit more understanding by using this kind of graph. So you try to monitor building conditions by using sensors, and then actually you also use this information to control. And then actually, in order to control, actually, the controller is between the sensors and the actuators, because the controller then goes with a certain protocol that is being put into place then to respond to any kind of changes within the sensor's response. And the actuators then access individual building equipment to then put that request into motion. There are different kind of inputs. We don't need to go too much into detail with that. So any kind of sensors run on different sort of inputs. There are analog inputs. So for example, you have an analog input, which is basically the measuring of the temperature, or the that is then being turned into a certain voltage. So by that, you actually turn basically the strength of the electronic flow or the electronic circuit into an analog input. There is a digital input, which is basically an on and off input, for example, that can be related to a certain activity of a device. Then there are non-intrusive load monitoring softwares that usually use digital softwares and algorithms to discover a certain conditions or characteristic of an electronic device or equipment that is being monitored. And usually the again, like the analog inputs are more constant, like constant conditions of that are being measured and then put into a frequency or being measured, and the digital inputs are more like on and off responses, etc. And I mentioned already that there are different kind of communications or protocols and codes, how digital protocols, and in older days they didn't work too well with each other, and nowadays they actually start to work with each other. And the reason why they didn't work with each other, these protocols, is because each protocol was designed by an individual company that was selling their building automation system. So BACnet, for example, is from Siemens, I think, corporations, and Zigbee is from Schneider Electric. So all these technologies, these protocols, they come from individual or from a group of service providers that actually established these protocols. And in older days, they didn't want to work with each other. So because they were competitors, nowadays they actually see benefit of communicating with each other, because there are so many different devices and so many different possibilities, so that intercommunication between these protocols are possible. So, for example, you may have a building that is running on BACnet technology for the most generic systems, such as temperature control, but Zigbee is a more recent protocol that also allows wireless communication. So that's why nowadays they actually are able to work together under certain circumstances. So this is one of the companies that has been in the business for a very, very long time. In building automation control, it's Siemens, but there are many others that actually do exactly the same. So this is just an example, one out of many, but again, like a rather prominent one in Europe and in Asia. And some of the operating modes, I already mentioned them, is again like trying to identify the occupancy in the building. Occupancy is often needed for regulation of thermal control systems, but also of lighting control systems. But occupancy is also very important, for example, for security reasons. So these sensors actually then serve different kind of system controls. So occupancy is one very important aspect, and in older days, occupancy was decided by when occupancy could not be measured, it usually was decided by or was controlled through time. So, for example, an office building not supposed to be occupied during the nighttime. So people set the time frame that from 8 p.m. towards 7 p.m. in the morning, the building is considered unoccupied, and by that, the systems can either shut down or can be reduced in their operations. And so again, like what in older days was just by setting a certain time frame, nowadays is often also then enhanced by actually censoring whether people are in a certain zone of a building or whether that zone is completely occupied or unoccupied. Another one is actually another one of an aspect of occupants control is then the lighting control. That again, like the building not only reacts to certain conditions of occupancy, but it also may respond to certain functions or that are required, such as the need for providing sufficient brightness in individual office spaces or in exterior spaces, or certain modes of lighting, whether they are decorative lightings and so on, So again, like they are partially occupancy driven, but they're also driven through timers and also through specific function related demands. HVAC control is usually the biggest system that is being controlled and automated, because HVAC is, or as you already know, is the provision of temperature, of heating and cooling, but it's also the provision of fresh air supply, as well as it is the provision or the control of the humidity. So there's so many different aspects that need to be overlooked and controlled, and also steered and then changed. And besides that, there is also a lot of equipment that is being involved. So on one side, you have actually the devices that produce the heat or the cold, which are the chillers, the chillers and the boilers and the related pumps. And then also there is the air duct system, or the circulation system that circulates the heat, brings them to the rooms, either through airflow or through liquid flow. And for this, you actually also need pumps, but if it's, and then for air, you also need then the control of the air handling units that actually then provide fresh air supply, and also then provide the right temperature of that air supply, usually done by these air handling units via air ducts. Another aspect is the water system, or the cooling, the refrigeration and cooling and heating system that is separate from the air conditioning. That is also then being controlled by a centralized HVAC system. Decentralized systems, you are going to learn about that later on. What the differences are between centralized and decentralized. Decentralized systems can be controlled as well. However, they usually they are not as complicated, I would say, or as advanced as maybe centralized air conditioning systems. Alarm systems are an important part. This is related to, for one example, to accessibility in the buildings, giving access to individuals that have access to certain areas, and preventing access to those that have not, but also to control who is having access, or who is using their access at a certain point of time, and also like the further control of the alarm system would be related to fire safety within the building, or to function or malfunction of individual systems within the building. So alarm is very general system that looks at certain aspects of whether there's something going wrong within the building, and whether someone is trying to get access to areas that they don't, or whether some equipment is malfunctioning, or whether certain conditions in the building exist that is not supposed to exist. And this alarm system is not only to basically provide a response or information of what is going wrong or what is not going wrong, but also then to activate and to certain protocols, or for example, communicating with those people responsible to look after. This can be like repair team, but that can also be security team, or that can be a fire alarm system that is being activated, and so on. And fire alarm system itself is also a separate system that is usually being installed. The fire alarm system has to be autonomous, meaning like it does not interfere with the overall building automation system. It has to be a separate system, but it can provide some output that can be used by the building automation system. Fire alarm system has only one function: to communicate and to respond in case of fires or in case of smoke within the building. And these fire alarm systems, they basically not only just then ring the bell, ring the alarm, but they also contact the in larger situations or in more serious situations, it contacts the fire department, it contacts the building operators, as well as then it contacts the occupants of the building in order to warn them and in order to tell them or communicate to them that they should evacuate in case that the fire alarm is a serious threat. And this is usually done through sensoring systems such as smoke sensors or through manual alarm that someone can push the alarm. And again, like it's usually building alarm system is usually related to the building that is operating, to the building operators, meaning like it should be accessible 24 hours, not only to the building operators, but also to the fire department. And when they come, that they can turn on and turn off certain equipment and get access to certain areas of the building that may be shut down. And besides, we already mentioned security system that gets more and more advanced, more serious. Security systems not only document access, but they also document like movement within the building, and usually there's a lot of camera systems being installed that are then interlinked with the security system. And information security, as I mentioned, is an important part. Usually, not only certain people should have access to the BAC system, and by that, it's actually quite important that these systems are independent, running independently, that they do not have vulnerable points such as internet access. However, many software providers and many hardware providers, they want to have internet access so they can update their protocols, etc. So it's a very, very delicate matter, I would say, of how basically information security can be provided for these buildings to prevent that people from outside can have access and control on building operation. For smart homes, everything is a little bit more dimmed down. However, people like to have the full range of possibilities. The smart home system is much more for individual comfort than it is on building operation and as a whole. It's much more like whether you can open your key with your phone, or whether you can check whether you left the light on, or whether you can whether you want to control the music that is being played in your living room or in other rooms or in the bathroom as well. All these things that are really like focusing more on individual comfort and individual enhancement of the personal lifestyle. And so these are less secured systems on one side, but they are also less advanced sometimes, and also like they are less, how would I say, they are less holistic in the sense that all this information comes together, is being shared, and provides a like intelligent approach of how to operate the building. It's much more driven by what the individual user wants. And again, some aspect like NFG efficiency is not really the main target here of the smart home installations. Even though people say like this is the main advantage, that you can control things and you can record things, etc. But you install so much equipment in your private home, it actually increases the electricity bill rather than reducing it. So, but people like it. People like to are open to new technology, use of new technology, and they usually embrace it. They like to try things out, and but they also sometimes neglect the fact that this also reveals privacy matters and that they may not have full control over. Especially because these smart home systems are sometimes also provided by large corporations that actually like to collect these data for their own purposes. So here you see an internet smart home system that is not that is basically run over an internet system where all the databases actually are stored in a cloud, and then all your information then has not only access to the user but also to the provider. And but the advantage is you don't need to install a lot of hardware systems or computer systems in your own private home. You don't need to install a database or a data collection, a service system in your home. It can all run over the cloud, and the automation protocols and can also run over the cloud. The so-called that's done by a LAN manager, and then you can actually just plug in your sensors as well as your actuators in your private home. Very often this is done by, for example, literally plugging it into a power socket. And then these devices start to communicate with the cloud using your Wi-Fi system in the house. Yeah, so many providers, many things that can be accessed and controlled. This is also like the enhancement of the so-called IoT devices, Internet of Things, any kind of house appliances that nowadays can be integrated into this network and can be become an IoT device, a device that is communicating with your internet system and your smart home appliance. And many of these actually exist. This is one example. It's called Dribbble. I think it works with one of the main appliance providers for sensors, which is called Next in the US. So here you see actually it's called a dashboard, where basically either over the computer or over a pad or over your smartphone, then you can overlook your electric appliances and activate them. Turn on your washing machine because you want it to be running in the time that you are not at home. Turn it on, turn it off. Activate the air purifier before you come home, or sensor the indoor air quality while you're away, and so on. Turn on the heater before you come home. Turn on the air conditioning before you come home, etc. All these things can be done, not necessarily focusing on energy efficiency. You can, but most likely actually focus on individual needs and convenience of the occupants and users of that building or residential units or whatever it is. Yeah, so here you see another example. This is also Dribbble. So this is the more computer screen interface, and this is more the smartphone interface. So you see it's slightly different, with some sliders where you can turn things on and off, or where you can also have it related to your media players, where you want to come home and then have the music running, etc. And also overlook the occupants in the building or in the unit or outside the unit. You can control a lot of things and more things that are necessary actually, but who knows? Yeah. And this is the history of tracking. Again, like you can become completely obsessed with these monitoring aspects. and some people use it for different purposes, and mostly it's individual needs. And again, like not only making your buildings itself become more connected, but actually also making your appliances become more connected, and by that also bringing these electric devices into the next level and into the next technology level. Yeah. That's why people actually like it, because there's something new and something they can try out, they can play with, and sometimes they are amazed and enjoy the privilege or the convenience that come along with it, and then often also quickly forget about it and then go back to the same old trades, because a refrigerator, for example, has a main function to cool your groceries, and not so much about telling you other things. So again, very often people are very excited at the beginning, and then the excitement phase also drops very quickly, and only some things stick while others actually start to disappear or become obsolete again. Yeah. So yeah, a lot of new possibilities, making your home become more connected, making your home become more communicative to you, providing more information, whether relevant or not, is up to you to decide. And this is the kind of technology provider in the market research trying to trace the roadmap of how the IoT, the Internet of Things, is going to change. And basically, right now we are somewhere in the middle. We can actually use these IoT devices to observe, to surveil, or to monitor, and to ensure that certain conditions are and have access to these conditions. But these IoT devices also become more and more then self-regulating, meaning like they also then start to observe whether you are present or whether you are not present, or what is your everyday habit. And they may actually start then to optimize their own operations according to your daily needs or occupant usage. And again, like they also then become more than proactive, or at least this is the idea of the providers, of the technology providers. They become more proactive, and then they also be able, for example, connect with your shopping list and start to either propose buying things, or actually may actually start to actually order things on your behalf. That's the idea and the hope of technology providers, because this will then actually also accelerate their incomes, and as they're more service oriented than just technology oriented. Yeah, Amazon is one very big example, how they actually drive and run their services by using this Alexa system to help you provide services, but then also like to control or to collect the information and the data on your behaviors, and then using it for their advantage to offer you purchases or services in this regard. Yeah. So Alexa system, I think I forgot the Apple system called Siri, all these things have advantages, and as I said, have disadvantages that sometimes you need to be aware of. That again, like this data that you produce is also data that is available to others, and they use it to offer you more, or offer you things that you may not ask for. And that's it, I think. I'm not going into detail. If you like to watch movies, I think 1 year ago or 2 years ago, there was a movie on this home automation. It's called Big Bug. And Netflix, I'm not sure whether it's still running. And actually, there are many AI related movies that try to address this topic of how robots and artificial intelligence will interfere with our lives or enhance our lives in the future, and become a prominent part in the way that we use buildings and that we use space. So let's see how this will change us and our behaviors. And that's it. So again, very basic, starting very basic and getting a little bit science fiction, but in principle, building automation systems are there to help us in the building operation, because all these data that are needed, they need to be collected. Ideally, they are connected in a regular way to optimize building usage and to actually optimize energy efficiency, especially for larger buildings. This has been the main intention. Security and safety has been another intention of these buildings operating control systems. Nowadays, it also takes on the commercial side. People experience that, again, it's a nice feature to play with, but also like it starts to become more and more an integrated part of our lives, if that's what we want. Okay, so that is it for the first third of our semester. There is an upcoming quiz starting from today, I think, until, let me see and let me share. End of slideshow. How do I get to the internet? Should be here. Okay, so this is our assessment activity. The first assignment is due today at noon, so you have about 1.5 hours left. I think 11 of you still have not submitted. And then you have the second assignment, which relates to smart buildings, that starts today, and you have 2 weeks to submit this one. And then we also have the quiz starting today at noon, and then you again, like, you have 2 weeks. So usually the quiz is related to cover the study break session. And the quiz relates to the lectures that we had so far. So it's mostly electrical installations, communication and IT, as well as I think building automation is still part of it, but may not be. And also the first session was integrated building systems. So all this may be the part of your quiz. And that's why you may also want to go and get the textbook. For those who did not do it yet, tomorrow I will be at SOAD. I will be in room 608, and I will take some of these textbooks upstairs, so you can come and see me at any time. You can just take a toilet break from your studio, come to my studio, and then basically get the textbook. It's as easy as that. You don't have to ask for a certain time, or we don't have to do a certain time. You just come to my to the studio, and then you just pick it up, and that's it. And then and for the quiz, I cannot control how you do the quiz. I can only control that you do the quiz on your own computer. Yeah. But whether you're sitting with your friends or whether you're on your own, that's up to you. And so I'm just trying to help you out a little bit, that when you take the quiz, pay attention to it, because it's only a one-time chance. You cannot log in and you cannot log out. And none of you can come to me and say, like, Ajahn, there was a situation where I was not able to complete it, and can I do it again? Because I cannot reactivate the quiz for you. So it's a one-time access. When you do the quiz, make sure you are in the location where you have stable internet and there you don't have any interruptions, because again, I will not reactivate the quiz for you. When you do the quiz, make it sure you do it from the beginning to the end. And don't stop halfway, because again, I will not reactivate the quiz for you. There is no way for me to do it, and I also don't want to do it. However, if you do the quiz, whether you do that on your own or you do it together with your friend, that's up to you. And yeah, so, and whether you use a textbook or not, that's also up to you. Because again, like, you're allowed to use the textbook, you're allowed to use whatever you have, you're allowed to use your notes. Just try to answer the questions and then move on. Finally, for the assignments, yeah, so please keep in mind, some of you have not yet submitted. Oh no, 3 of you have not yet submitted. Here, this number, not 11. So 11, there are already 11 groups, and then 3 have not yet submitted. If you don't have a group yet, then team up as a group, figure out who that is, and submit it as one group, and then you're done. And yeah, and then what else? Yeah, this one is coming up starting from today, and then the others are coming up later. Are there any questions? So next week, no class. Next week is study break. However, do the quiz. And also look at your assignments. Then you can do that again as a group, maximum group of 3. And then the last thing is, so all these assignments, some of this work, you can later use it for your poster. However, the difference of the final project will be is that this has to be, I don't know yet. I will come back to you. But again, like, this can be part of your final project. So make sure you keep your assignment. Don't throw it away. Don't delete it, because you may need it later on, or you may need some parts of it later on. That's it, I think. Are there any questions?
I have a question, Cup.
Yeah.
Oh, so the week after week break, would this class be still online or on site, Cup?
I'm not at the SOAD today. Yeah. If you want to talk to me in person, you can talk to me tomorrow. And after I finish online, then the class is completed for today. But if you have any questions, you can come and see me tomorrow.
Okay, Cup.
Oh, all right. Achan, can you tell who are the other two who haven't submit? I still don't have a group. Okay, let me go and check. But I'm not sure I can figure that out. Let me just check. I think I should be able to figure it out. Okay, well, So what I see is that there is one group called Cow and Friends, which is Yada Nako Sochirat, Larun Chanont, and Achita Yotsri. These three, they teamed up as a group, but they did not submit any files or any documents. So there is one group called Cow and Friends, 3 members, no submission, but you already teamed up as a group. That's the information I have here. And then who was asking? Let me check. Pia Patanagun. So you did not submit either. So that's something I cannot see from this information. So Pia, if you have not yet any group, then you may actually do either one or two things. So there are some groups, obviously they have submitted already. You may just do this assignment by yourself, and then you try to find a group for the next round, where these are groups of 2, and maybe they take you in. Yeah. So that would be my advice to you, because right now I cannot see any other students who did not yet submit. I only see that there is one group